Okay, guys. Before we start the class, in the last time, I think we spent maybe 2 weeks to play the Arduino. Okay, and also with LoRa. So right now, I think each groups we have 1, 2, 3, 4, 4 groups have your own device, and you can send some message with the ID. Okay, through the LoRa. And of course, someone will say, Professor, can I check out by myself if I can test any kind of further of the device with the Arduino and the LoRa? How can I know that we already received the signal, okay, from the gateway? So I think here, and also in your cell phone, you can download any kind of the software or apps, what we call the MQTT. Okay, MQTT here. So for this interface, you can download from the Microsoft Store. Maybe if you use Windows 10, you can download the MQTT box. Okay, so just the keyword MQTT. So I already provide some of you of the host, but maybe in the last time send a line message for you, so you can find the host address. I mean, this is from the LoRa gateway. It is 114.1 and 15 and .61 and 211. Okay, so this is the IP address. Let me enlarge of this one. Okay. So here, yes, 140.115 and .61 and .211. Okay, so this is the host that you need to key in. So you can not only use your laptop, you can use your cell phone. So for me, I just want to show the screen, but it's a different. So for me, I already download the MQTT, okay, MQTT tool of the iOS system. And any kind of the apps is okay, but you only need to assign is one first host, okay, and the second one is please make sure that your protocol is MQTT TCP protocol, because there's a lot of options for the different kind of the apps, but please find from the protocols and also the host. Okay, so the host, you need to type the IP address, and the protocol, make sure that this is MQTT TCP. Okay, some of the apps, this is the default. And make sure the next third part is that your username and your password is MQTT. Okay, the same MQTT. Okay, so also you can find your maybe some Microsoft Store of the MQTT box. It's the same. It's the same. Okay. Okay. Can you find that? Anyone? Okay. Let me see if you guys already figure out. Okay. Address, yes. Address is yes, the host name. Yes. Yes. So your the password. Okay, so let me show you. You don't need it. You don't need it. It's a generate automatic. So after you already connect, okay, status is connected. Okay. Okay. Oh, connect here. Okay. Yes, port 预设的1883 ，OK。I think this is because there's a lot of apps and software, but just only you know that you need to type is the host, and make sure that you already have your username in the small size of the MQTT, not the capital one. Okay, the small character. Okay, MQTT. Okay, so if you already can connect, okay. Next, need to know. Sorry. So can you connect to the server? Not yet. No. Okay. But don't worry, because right now you cannot receive any kind of a message, because this is the MQTT will be like the news host. So you need to type the topics you try to subscribe. Okay. So for this class, please. Okay, let me enlarge of this. Okay, this is the topic you need to subscribe. LORA/ISPK. This is the topic you need to subscribe. Okay. So when you subscribe this topic, and if you already have your Arduino, okay, right now some of you already connect, so you can connect. Let the Arduino send a message, so you can find the message from this topic on your cell phone. So you need to subscribe the LORA/ISPK. So anyone already subscribed? And you can send a message with your Arduino device. Okay. 可以吗？有收到吗？还没。哦，你那还没接 LoRa 的部分。对，都是一样的概念。Yes.
This is the IP address.
You just
the number?
Have the
Yeah,
address,
the number, the
address and the username and the user password.
How does do I have it?
IP.
Yeah, I have it on my phone. Can you go?
And QTT. Yes. So don't worry, you can try it. I already left all the setting through the line message. So if you can find our line groups, you can find the message already passed. maybe a few days ago. Okay, and if you right now have your own LoRa device, so you can let the device send a message to the LoRa gateway, and of course, it is okay. You can find the message from your cell phone MQTT. Okay. Okay, so let's before the class, I need to tell all of you. Okay, so you can check the message by yourself. Okay. So any questions? No? Because I need to continue with the class. So you can try it. Try the MQTT function by yourself. If you have any questions, you can use your line, and we can. Yes, I mean that if you in the last week we already sent Arduino message with the ID and some artificial number, okay, to the LoRa gateway. But in the last time, I showed the server from the LoRa gateway, so you guys can see. Oh, show the data. But however, if you try to, if you try to test the program and Arduino at your homework, and how can you know that the message already upload to the LoRa gateway? So the MQTT will be the interface to understand. All right, your message already and successfully upload to the LoRa gateway. Okay. Okay, so guys, please, you can try at your home. But right now, I need to continue the disaster. Okay, prevention, the sensor and the transducer. Okay. So in the last time, we already talked about the measurement concept, right? So last time I already showed you what is the interest of the measurement from the aspect of the engineering and also the physics and the environmental interest. And we already talked about what is the resolution, right? And what is the accuracy. So it is the basic concept at the beginning. Okay. So we already talked about what is the resolution. Depends on your fault scale. See, the resolution. Well, I'll show in terms of the fault scale. Maybe the 0.1 percentage of the fault scale. Okay, so we already talked about of this concept in year with go, and also we talked about the sensitivity, reload shift, and also this is the IP protocol, and the first one is the protection against the dust, and the next is the level of the waterproof. Okay. So I already showed you what is the sensor calibration idea. So this is the real index. Just I say, maybe this is the pressure or this is the displacement. And the other one is the measured response from the transducer or sensor. Okay, so mostly it will be in terms of the voltage, electrical voltage or current. Okay, So how can I change to the electrical voltage and the current to the real one? We need a rating curve. Okay, so this is the calibration data. Okay, and we can get the rating curve. So for the most case, you can see here, this is the, with much varied data. For this one, would be much ideal for the response. Okay, so this is the, for the last time, the case of the B, right? Okay, so for the other one is the B, which the higher variance of the measurement. Okay, but however, I think this is okay because if you can use the staking or the average, you can get the mean value. Okay, and maybe you can reduce the error of the measurement using the average idea or staking idea. Okay, but however, if you have some drift like this one, okay, so we need a zero drift shift to the real case, and if you have a sum of the slope change. For this one, this is the slope change of the linear regression line, and this is another change from the linear to the maybe the this is the second order of the polynomial. For this kind, we may need to recalibrate again, recalibrate the sensor again. Okay. And in the last time, we already talked about what is hysteresis. Means that you will have a different paths on the increasing and also the decreasing. This is not the same path. So this is what we call the hysteresis. Okay. So in the last time, we already talked about the idea of this basic measurement concept. So the next, I will give you a very quick introduction and of different kind of the sensors. But I'm not sure how many you already listened some of this topic from the Professor Lin class. Not yet? No? Okay, I see. So the first one I would like to talk about is the mechanical instrument. This is the typical one, what we call a dial gauge or dial indicator. So I think most of you, all of you already use this kind of the dial gauge. Okay, so this is for the displacement. Okay, very useful, but you need to manually read in the ticks by yourself, right? Okay, so this is a mechanical instrument. And also, of course, you already have a caliber. In the previous, we need to check out the ticks by ourselves. But right now, we already have this kind of the digital display. Okay, much convenient for you. So, and this is another micrometer. Okay, so you need to read the ticks by yourself. But I think this is a very robust measurement ever. And this is for the burden tube pressure gauge. To what? To measure some kind of the air or the liquid pressure. Okay, so they use the burden tube. This is the burden tube. Okay, so I have an inlet of the pressure from maybe air or the liquid. And with this burden tube, you can find this is a corresponding ticks. So we can know how much of the pressure so far. But of course, you need to calibrate the response and the pressure using the rating curve. Okay, so that's why we can understand, oh, actually, this is the how much level of the pressure we can make. Maybe I can have some video of this for you. Anyone play this?
YouTube. This is a short video.
Okay, so this is the burden tube.
Bourdon type pressure gauge works. So
Let me
this is a full
have,
mechanical gauge. It has no electric or hydraulics components.
So let me speed up.
And let's remove the needle. And screw to the face pressure gauge, right? So it measures pressure, gas, or in fluid form.
Okay. So if you have a pressure,
let's make an example. Let's play with our mind and think of air, for example. So if overpressured air comes in to this inlet, it travels up here and forward into this pipe. This is actually a bended copper pipe straight out. Pressure increases, the pipe wants to straight out. So imagine, for example, your garden hose when you turn it on. It wants to rise, right? Almost like
maybe with
like a living
air
snake or
pressure
something.
water pressure
I don't know to
equipment.
explain it better, but it wants to straighten out. Yes. So watch what happens.
A burden tube.
If we stretch out the pipe.
No, you can see
Yeah.
here. Yeah.
The needle moves clockwise.
I have a pressure, so the tube will have a different
pressure rises in air state this time, and it can also be liquid.
So I think this is a very quick understanding of this burden tube. Where is my Okay, so I already give you some link. If you try to find a commercial product, you can here. This is the typical one of the burden tube. Okay, so just as I said, the burden gauge. Okay, here, the purpose is try to measure the pressure from the air or the water pressure. Okay, for this one, you can find a manometer with this. This is the water, and this is the mercury. So with a different kind of the density, you can use this to measure the water pressure here. Okay, so this is the concept. Okay, with the different head of the water. I'm not sure. Do you know what is the water head? The head of the water. Some of you, okay, some of you know. Okay, the water head in terms of the pressure. So, but just present in the different meter height of the water. Okay, so it's a very simple idea. Okay, so it's called the pressure head, or the head of the water. Okay, so this is the idea of the manometer with the burden gauge. Okay, so this is the practical picture. Okay, I got it from the Zhengwen Reservoir. It is the most big reservoir in the Taiwan. More than I think maybe 50 years old. So beginning of the construction of the earth dam, they put some tubes and try to measure the earth and the water pressure inside of the dam. Okay, so they use the tube and connect to some of the air pressure and also the burden gauge indicator here. Okay, so this is to monitoring. I mean, if you have a dam, just you present, right? And for the earth dam, Okay, and may I have a very quick understanding for you of the basics of the dam construction. So in the last time, maybe I say this is the earth dam. Earth dam means that made by the sand and the clay, and in the inside we may have what we call the core layer. Okay, and the outside the shell layer. And for the core layer, it is mostly use the clay with the very low permittivity of the water. Okay. I mean the transportation of the water inside of the porous media. Okay. So in a clay, because this is a very fine particle, so means that there is no more air or the pore volume inside of the clay. So the transportation velocity of the water is very, very slow. So here you can find, if you guys have some idea of the soil mechanics from the water head, so you can find the inside of the underground water table inside of the earth dam will be like this one. So this is the water level, underground water level. Okay, because of the core with the very low permittivity of the water. Okay, so this is the earth dam idea. But however, if you have some problem, I mean that if you have some leakage path, what we call maybe the pipe issue, okay, was scour issue. Maybe we have a very severe scour issue like this one. We have a path. This is the empty area. Okay, so maybe the water pressure will change to this because we already have a path that the water can go through. Okay, so to prevent this kind of the issue, maybe we need some so this four will be the water pressure gauge. Okay, for this one, you can measure the pressure of this water in this location. Okay, this is the H1, and this is the H2, and this should be the H3, and this is maybe for this or for this. Okay, as H4. So for the normal situation, you will find, okay, the H1 will have the highest water pressure, and the H2 similar, because it's still in a shear layer. But in the H3 location, you can find it should be a very low water pressure head. Okay, and for the H4, for the normal situation, if this is the water level here, of course, there is no response of this sensor because there is no water pressure at all. But however, if just as I said, we have a seepage path for the pipe problem. So right now, this is an abnormal situation with the water level increased to here. So maybe there's a response of a positive water pressure. So for the monitoring of the dam safety, this is the basic idea. So I just talked about one problem of the potential variable. This is the path of the water underground water pressure. So for this, the burden gauge of course, it is already 50 years old. They try to tell me the water pressure response in a different location. So you can find this is a lot of indicator, right? Means that we have a different. Maybe this one I already have a pressure here. Okay, it depends on your the size of the dam and of course your budget at that time. So we will discuss this idea maybe in the next chapter. Okay, well, I'll let you know further understanding of this kind of the measurement. But right now, I just trying to deliver the principle of the sensor and the transducer in the beginning. So in the next chapter, we are talking about the signal processing, and for the next chapter, we will integrate of this idea and use the potential variable for different kind of the application. But for the mostly use the dam safety as a case for you guys to understand how can we read the response of the monitoring, and then how can we interpret the data of the monitoring. Okay.
I read online that this kind of pressure monitoring was very difficult.
Difficult?
Yeah, very difficult.
Yes.
So is it used everywhere, and or does it require some specific investments?
You mean that for this case?
Yeah, because this case seems to work, but it doesn't seem to be the most popular technique.
Yeah, sure. But because I'm trying to show the basic idea of the one kind of the target we need to monitor. But of course, this kind of the technology is very old. Okay, so right now, next we will show you some kind of the electronics technology or the fiber optic knowledge. Okay, will be much efficient for this kind of the application. Yeah. Okay, so the previous one is mechanical, and now is trying to show you a pneumatic instrument. So this is use the air pressure as a source. So you can find here, this is the basic idea. So I have also the pressure gauge, maybe from the burden gauge, the burden cube. So this is the outside of the water pressure or the environmental air pressure. Okay, so I give you a source of the pressure. But however, if this is larger than the outside, this is not a balanced one. So you can find this is not. You can find this is a loop. I'll come back to the vent. So you need to change the level of the input pressure until the pressure will be balanced with the outside, maybe the water pressure. Okay, so this is also the manually. So you can find this is a manually instrument at all. But for this kind of the instrument, usually for the geotech, it is used for the DMP or the PMP. Okay, you can find the keyword by yourself. This is a DMP and or the PMP pressure meter. Okay, for this one, this will be like drill a borehole. You drill a borehole and put a sensor inside of this. Okay, so I give a source of the pressure and an increase with the tube. So I can understand the stiffness of this layer. Okay, so this is the basic idea. So for the PNT, I need to use this kind of the instrument to measure the pressure response. Okay. Sorry, I didn't find the picture of the DMT or PMT here. So, but I think you can Google it very quickly. It is a geotechnical instrument to measure the stiffness of the soil layer. Okay. So the next, I would like to go to the electrical instrument. So the first one, guys, you need to understand this is the basics of the electrical instrument at all. What we call the strain gauge. Okay, strain gauge. So it is supposedly that all of you already learned the basics of the physics. Okay, so you already know that electrical current, electrical voltage, and electrical resistance, right? So you did have the load, Ohm's law for these three index. So based on the idea of the electrical principle, we made an instrument like this one. This is what we call the strain gauge. Okay, so this is the real one. Maybe later. And do we have the strain gauge in our lab right now? Right now in our lab. Okay, maybe later I can bring you a small strain gauge. It is very thin types of the sensor. So for right now, they use this electrical path. This is the wire. So to change, to have a strain gauge like this one. So for example, let me show you. Yeah, okay. If I put this strain gauge maybe directly to this word, I attach this strain on this word, and maybe I have the extension because this word have some the strain because of the external voltage or earthquake. So this word change means that meanwhile simultaneously your strain gauge have a different extension because of the external force. So from the Ohm's law, if I already have an input of the voltage to this electrical circuit, I mean the strain gauge, and I can read the output of the voltage. So how about the idea using the strain gauge? Because if I extend the strain gauge, means that the original electrical resistance change, R change, right? The R change. So if I have an input of this originally V0 into this electrical circuit, but with a different resistance change, I mean that I can have a different output change, right? This is the basics of the Ohm's law applies to the strain gauge. Okay, but just as I said, it is supposedly this is a very basics of the physical law. So maybe you already know that. Alright. Okay. So from this idea of the strain gauge, right now, because we can use this to detect the change of the voltage corresponding to the alternate force, right? So it means that, oh yes, we can use the strain gauge to measure any kind of the response if this can be changed to the shape of the strain, or mean the strain of the strain gauge. Okay? So the next, I would like to introduce a very good development for the increase the accuracy of the strain gauge, what we call the Western bridge circuit. Okay, I'm not sure. Some of you already learned on the electrical circuit series before, right? Maybe in high school, not sure. Okay. So supposedly you already know that how to solve this circuit problem. If you already forget, please go back to familiar with the circuit again. Okay. I would like to say for this R1, no,
Sorry, we only have this one because the new one already
attached on the okay. So you guys can see this is the example from our lab. The blue one is a small strain gauge. I attach this kind of the tube for the different application or displacement. So you can find yourself. So I attach several strain gauge based on the Western bridge idea. So you guys, if I have know like the resistance value from the R1, R3, and also the R2. R2 is the variable strength, so we can change the resistance by ourselves. So I already have these three resistance, means that I can solve the resistance of this X directly, right? If I already know these three and I already know that the input and output voltage, means that I can estimate the value of this strain gauge, the resistance of this strain gauge, right? So based on this Western bridge circuit, means that I can use this kind of the circuit to provide very high accurate or very high sensitive measurement at all. So if I have a very small strain, I can detect from the Western bridge. So anyone have I mean, some of you already have some problems so far. But I would like to say, I'm trying to point out that the Western bridge, the purpose of the Western bridge is trying to increase the sensitivity of the strain gauge, especially for the very small strain change. Okay? And of course, if try to increase, again, then we have a very quick homework for all of you. You can Google it or you can find any kind of reference. Please, first one, I already showed that how the Western bridge works. So you can do by yourself. Okay, this is the basic idea. But just as I said, the purpose of the Western bridge is trying to increase the accuracy and the sensitivity. So for I just show you the quarter type. 1, 4 types of the bridge means that only one of these electrical resistance is unknown. But if I can use half type and a full type, what is that? What does that mean? Means that maybe I have half of these registers unknown, and also all of these registers unknown. But how can it work? Okay, so please, maybe I think we may make it as a group homework. So we already have 4 groups, right? So each groups you need to come up with a report with your team member. Okay.
What kind of report?
In Word or in PDF file. Okay. But I would like to say, please do it in a formal format because maybe you may have a Word format. So guys, you need a preface and all, okay, and also the outline because I try to train to all of you have a formal format of a report. So you need an outline, and maybe in the beginning of the chapter 1, you have an introduction and all. It's a very quick introduction. And chapter 2, by yourself, you need to outline your content. Okay, and for each description, okay, you need a formal format, and also if you need a figure, please also have a caption of the figure. Okay, and of course, if you cite by another reference, please include the citation. Okay. Also, you may have a different kind of figure again, figure 2. Right? Okay. Supposedly, this is the formal format of a scientific report. Okay. And finally, you may have your own conclusion and suggestions. Okay. And of course, final is your reference list. Your reference list. So I think I need all of you to make this kind of the report. Okay. With your team member. Okay.
For this?
Yes, for this.
Okay.
Okay. Tell me what is the wisdom bridge? Also, I already tell you a little bit of this. And what is the bridge principle and how can it works? Okay. And of course, you need to show me. Just as I said, I just show you a quarter type or the quarter bridge of the wisdom bridge. This is the first one type. But right now, we also have a half type and a full type of the wisdom bridge. So please check out and tell me what's the difference and what is the advantage of the different type and how can you apply this type to the real measurement. Okay, just as I say, for this case, I use the wisdom bridge to increase the sensitivity of this tube strength. Okay, but here I just only maybe use 4 to 1, 1/4. Only one unknown, the other one known. Okay. So this is our new homework. Okay. So how many days? Can you do down this? 1 week? No. No. Someone say no. 2 weeks. Okay. 2 weeks. Okay, I think 2 weeks is okay because we have a holiday in the next week, right? Also remember that you don't need to attend our class in the next week because we have a spring break in the next week. Okay. Right? Next week. Yeah.
For the whole university?
Yes. Yes. From the Wednesday to the Friday. No class in that time.
But Tuesday you get class?
Tuesday. Wednesday, Thursday, Friday, no class in that time. So we have a 3-day holiday in the next week. But Monday, Tuesday, we still have a class. Okay.
They should have meeting on Wednesday.
I'm so sorry. It's from the Thursday, Friday. Okay. All right. So we still have the class at Wednesday. So you have any plan to visit the Taiwan in that time? No. Because it's a very big holiday. So I think you need to plan earlier, because maybe you cannot buy the ticket very conveniently in that time. Okay, and we will have a very big traffic jam, okay, in this holiday. Because in our culture, we will have what we call it I don't know how to say that. Okay, someone can translate the word for me. Okay, because we have a culture to find the lost parent, for lost the family members. Okay, and each year we will have this kind of habit, because in Taiwan most of the past person is buried in the ground, so we need to clean up of this the tomb. Okay, and for the big family, they will also use this time to get together. Okay.
Yeah, the
Yes,
same.
yes.
Exactly the same.
In the same.
In October.
Oh, in October.
Yeah.
In the France. Okay,
Yeah.
okay. So in Taiwan, for the Chinese people, it is almost in this time, the April time. What we call the Qingming, the festival, Qingming festival. Okay, next. Guys, so you already know that the resistance, okay? So next, I would like to talk about the capacitance, capacitive reactor. So this is the same idea for using the electrical circuit or the electrical principle. We use the capacitance. So you guys, all of your cell phone use this kind of the principle for the touch screen. Okay, for your screen, they use this capacitive principle. So when you touch the screen, means that in this area, you may have an increase of the electromagnetic wave and increase the capacitance in that area. So based on this idea, the screen will understand which location you push. Maybe 20 years ago, the first kind of the smartphone is not use this kind of the capacitors. It use the registers. Means that you need to press the screen so that you understand which location you press. But that means that you need harder to click or press the button. Okay, but for now, if you use the capacitance idea, you can easily smooth and easy to click. Okay, and this is for the other capacitance commercial product. This is for the temperature measurement. Okay, based on the idea of what? Of the different metal. Because in a different temperature, the different metal will have a different response of the strength, right? So, oh no, it is a humidity. Also, it is the same for the temperature. So for the different humidity or the temperature, there's a different response of the different metal, right? So with the different spacing, you may have a different capacitance. Okay, the capacitance depends on the what? The distance, the spacing of these two metals, right? Okay, so when we have a spacing change, means that we may have a capacitance change, so we can measure the change of the temperature, of course, as well as the humidity. Okay, this is the same idea, And the next, I would like to show you a very common one especially in our civil engineering. This is what we call the LVDT, linear variable differential transformer. Not a movie of the transformer. Okay, you guys already see the transformer before? No, really? You also have maybe 5 series of the transformer, but I would like to say the first one would be the best. Okay. Okay. Here, I think this is the same idea of the electrical circuit. Okay. Here, this is the principle of the prime cord to generate the electrical field. I mean the electromagnetic field. Okay. And the secondary one is to response the change of the electrical magnetic field. I don't know if you guys already memory the concept of the generation from the circuit to the field, EM field, and the EM field change can generate the electrical voltage and the circuit, what we call the Faraday loads. Okay. So if I have this tube inside of this field of the electromagnetic wave, means that change the response of this secondary one. This is the source of the field, and this is the response to output the voltage. So if I change the field, so I can tell you, whoa, this one. This is the source. This is the secondary, first part and the second part. So if I have a change of the electrical field, because right now this is a lot of electromagnetic field, EM field. So if I change the status, so may I have a different response from the secondary force, the part 1 and the part 2. Means that if I can, through the calibration, I can know the position of this LVDT. So the LVDT mostly used for the displacement measurement. So this is the idea of the product. Okay. This is the core, the central rod, as I say. So if I try to measure the displacement, okay, so I can use the LVDT to know that the displacement of this central rod. Okay, so this is the product of the commercial one. Okay, this is the LVDT, mostly to measure the change of the distance. Of course, this another one of the based on the LVDT. This is what we call the DCDT. But I just let you know, understand this is a upgraded one of the LVDT with amplitude regulator. I mean that to have a much clean signal at all. Okay, so you can find this is a lot of component for upgrade the LVDT to get a clear and accurate signal at all. Okay, this is the idea I just want to show you. Okay, next is potentiometer. Okay, you can find this is all based on the electrical circuit with this kind is resistance, but it is a variable resistance. Means that it can change the resistance by this kind of the mechanical action. So if I can change the resistance, so it means that I can change the output by ourselves, right? So can you tell me where can I find this? Anyone know that? This is very common in your home. Yeah. You know? You know that? No. No. If your home have the older television, you need to have a change it with a louder, volume louder, smaller. Okay. Use this kind of the tensiometer. Okay, when you change the resistance, so the sound will getting louder or smaller or based on your registers, right? Okay, this is the basic idea. How about the other application? If you try to use this kind of the potentiometer to measure the engineering interest, I just show you what kind of the engineering interest, the stress, strain, right? So yeah, so if I can use this kind of a potentiometer, maybe I can measure the displacement. If I can combine it with some of the wire, okay, like this one. This is the potentiometer. But if I can fix with the wire, and maybe this is fixed on the ground. So if I have a settlement of this surface, means that if I have a counterweight, so I can change the resistance of this potentiometer, so I can understand how much displacements we can have. Okay, so I think this is a very basic idea for the potentiometer. Okay. Okay, so far any questions? Because in the next I would like to introduce the very important technique so far in the electrical circuit. This is what we call the vibrating wire transducer. So I think this is very easy principle. Here, this is the fixed wire, maybe made by steel. So you guys already know that the natural frequency, I mean the vibration frequency, right? Okay. If I have an extension of this wire, or maybe a small variation, the shortage of this vibrating wire, so the natural vibrating frequency will change, right? Because of this displacement. Okay. So based on this idea, if I have electrical cord to detect the vibration frequency change, so means that I can detect the change of this displacement as well, right? So that's why we call the vibrating wire transducer. So you guys, you need to go back. I need to go back. So for the strain gauge, so for the capacitance, so for the linear variable differential transducer, transformer, and the VDT. Okay, you guys, you know that when you go back to this, you will understand, oh yes, if I have a different kind of the resistance or the capacitance, I may have a different sensor output, right? So based on the calibration curve, I can understand the corresponding target or parameter in the environment. For example, the pressure or the distance. Okay, so I can easily get the response, temperature, displacement, pressure, okay, at all using this kind of the rating curve, right? But somehow, I would like to say, can you give me some shortage? Maybe using the electrical instrument like the strain gauge for the real application. For me, one example, if I try to measure a slope, but I only can have a power supply maybe 100 meters away because of the location situation. So I need to extend the transmission cable at least 100 meters long, right? But based on your idea from the electrical circuit, when I increase the length of the electrical circuit, the length, what will be the sequence? Means that maybe I have a smaller response because the resistance of this the 100 meter transmission line, right? So means that if I extend to the 200, 300, what is the result? The signal will be smaller and smaller, and we have much higher noise. So sometimes we will call this is the signal to noise ratio. This is a very important index for the measurement. SNR, signal to noise ratio. So when you have a longer distance for the transmission line, especially using a strain gauge or the capacitance transducer, means that the signal, the level of the signal, original signal, I mean the output one, will decrease. And along next to the transmission line, you may counter with the noise. So the level of the noise will increase. So it means that the SNR will decrease, right? So this is not so good for the measurement. It means that originally, maybe this is our signal, right? Output of the sensor. But however, if I have a longer transmission line, maybe 100 meter, 200 meter, also maybe decrease to this one. Okay. The level of the measure will be decreased. And simultaneously, I have a lot of noise. Right. Because the noise level will be the same. So for this, there will be, okay, fine, I still understand what is the measurement level and all. But for the second one case, you will get a very hard interference from the noise. So it means that you may not get a very good result from the sensor signal. So this is a problem. if you use a traditional electrical circuit with the strain gauge or the capacitance sensors, you may have this kind of the problem, the low SNR, when you have to extend the cable. But maybe we have 2 minutes. Okay, so let you guys think about it. If I have a signal of this kind of the vibrating wire, so what is the result? The result from the detection of the frequency may be like this one. Original. So I just count how many steps, means like what is the frequency of the vibrating wire, right? If I have maybe extension of the distance, maybe I have a smaller response of this, right? So this is the original, this is the result from the extension. But however, I just count how many numbers of this change. I don't need to measure the value. I mean the value. Maybe this is a 5 or the DC. I don't need to count. I mean that no need to quantify the value of this response. I just want to count number 1, number 2, number 3, number 4. So for the vibrating wire, I can easily get the frequency. Just count. I don't need to quantify the level of the results. So let you guys to think about what is the advantage of the vibrating wire sensor. Okay? So see you next time. Next week. Bye. Arduino 的练习的作业，今天教的那个，上次是出什么？用那个2到3个灯的那个呼吸灯，好用对，呼吸灯。你可以要含你的 coding， 还有你可能弄一个图片或影片交上来，让我知道你完成。所以是一组啊，对，一组交易。